Welcome to my problem solving class of Advanced Microeconomics. Today we are gonna solve problem set 3, which is on static games. So let's get started. First problem is 3.1, Cournot competition with efficiency changes. We consider Cournot duopoly model with two firms selling homogeneous products simultaneously and independently. Choose their output level Q1 and Q2. Firms face a linear inverse demand curve. EQ equals 10 minus Q, where Q equals Q1 plus Q2 from output of firm 1 and 2. Assume that firm 1's cost function is given by TC1 Q1 equals 4Q1. So its marginal cost is 4. Assuming that firm 2 also has this cost function with a marginal cost of 4, find each firm's best response functions and depict them in a figure with Q1 in vertical axis and Q2 in the horizontal axis. So then find the output each firm produces in equilibrium. B, consider now that firm 2 invests in cost-saving technology, which transforms its cost function to TC2 equals Q2. So marginal cost is now decreases to 2. That means firm 2 has gained efficiency in production. So our problem is to repeat the analysis in part A with this new cost function for firm 2, assuming firm 1's cost function is unaffected. That means remains the same. Finally, we have to compare two results from part A and B. So let's start our solution. 3.1a, finding I's best response function and Cournot-Nash equilibrium. Firm 1 and 2 solves the following profit maximization problem. Then taking first order condition with respect to Qi and assuming the interior solution for Qi, we have got this equation, and after rearranging the best response function BRF of firm I in response to firm J's is given by this figure 3.1. So figure 3.1 shows BRF when I equals 1. That means firm 1. So BRF equals 3 minus QJ. That means Q2 divided by 2. So if we let I equals 1 and J equals 2, the best response of firm 1 becomes this one, 3 minus Q2 upon 2. Similarly for firm 2, if we let firm 1 be J and firm 2 be I, then best response function of firm 2 becomes 3 minus Q1 upon 2. And this can be shown in figure 3.2, best response function, best response curves of firm 1 and 2. And firm 1's BRF is in red and firm 2's BRF is in blue. And using this BRF, we find the Nash equilibrium, and this is the point for Nash equilibrium. Using these two BRFs, we can find Nash equilibrium, Cournot-Nash equilibrium at this point. And if we simplify these two equations, Q2 equals, to find the crossing point, we substitute the best response function of firm 1 into firm 2. Then we get this best response function, and we find that Q2 equals 2 and Q1 equals also 2. So we have seen that Q1 star, Q2 star, which is equal to 2. Now 3.1b is finding firm 2's best response function when firm 2 has new technology in hand. So profit maximizing condition for firm 1 remains the same, but for firm 2, farm 2 changes because investment in cost saving technology. Here's the profit maximization problem for farm 2. And from this, taking first order condition with respect to Q2 and assuming an interior solution for Q2, then we have got here if Q8 minus 2Q1 minus Q2 is equal to 0. After rearranging, we get Q2 equals 4 minus Q1 upon 2. For farm 1, best response function, it remains the same, 3 minus Q2 upon 2, Q2 upon 2. To find the to find Cournot-Nash equilibrium, substitute this best response function into of farm 1 into best response function of farm 2. That means Q2 is now, we know that Q2 equals 4 minus, so if we put this value from the best response function Q1, Q2, Q1, Q2 equals 3 minus here Q1 equals 3 minus Q2 upon 2. So we get Q2 equals 10 upon 3. So substituting the optimal output of farm 2 into the best response function of farm 1, we get Q1 equals 1.33 here, which is equal to 3.33. As a result, farm 1 is now producing 1.33 and farm 2 is now producing 3.33, which is here now Q1 star Q2 star, which is equal to 1.33 and 3.33. Now, and in 3.1c, we have to compare the results from A and B. So when we compare these results, we have seen that Q1 and Q2 was Q1 and Q2 both were 2 units, but now Q1 equals 1.33. That means it decreased, and Q2 equals 3.33, which increased. So it is obvious because farm 2 has got the cost savings technology. So this ends our problem 3.1. Problem 3.2, and it is a lobbying game. So here's the matrix for the game. So let's consider the following lobbying game. 2 firms simultaneously and independently decide whether to lobby Congress in favor of a particular bill. When both firms or none of them lobby, Congress decisions are unaffected, implying that each firm earns profit of 10 and 10. No lobby means 10 and 10. Or if lobby and lobby, both lobbies, then they receive -5. That means they lose. If instead only one firm lobbies, its payoff will be 15, since it is the only beneficiary of the policy, while the other firm did not lobby, collapse to 0 in this form of the game. Now, in this normal form representation of the game, we are asked to find pure strategy Nash equilibrium of this lobbying game, then find mixed strategy Nash equilibrium of the lobbying game, and finally we have to represent them graphically. Graphically represent each firm's best response function. So take the first one, A, find the pure strategy Nash equilibrium. So let's take the underlining process. So identify each firm's best response function. So let's first take farm 1's best response to farm 2's strategy. So BR1, when farm 2 applies lobby, so farm 1 is taking no lobby because the farm 1 has option -5 and 0. So 0 is great, and 0 is more than -5. That's why farm 2 takes no lobby. I mean, farm 1 takes no lobby. And if farm 1's strategy is no lobby, then farm 2's strategy is no lobby, then farm 1 takes lobby because the comparison between 15 and 10, 15 is more, so farm 1 take 15. Similarly, for farm 2, if farm 1 has a lobby, then farm 2 takes no lobby because -5 is less than 0. If farm 1 plays no lobby, then farm 2 has taken lobby because 15 is greater than 10. So therefore, there are two PSNE, pure strategy Nash equilibrium of this game. You see the underline, both underline, one is blue and other is orange. Two underlines are, we have got two underlines in two cells, lobby, no lobby for farm 1 and no lobby, lobby for farm 2. Now for 3.2b, we have to find mixed strategy Nash equilibria of the following game. That means the game of the lobbying game. So in order to find the mixed strategy, we need to consider that the probability distribution of both firms taking their strategy. Let Q be the probability that firm 2 chooses lobby, and 1 minus Q, obviously, the probability that she chooses not lobby. So the expected profit of firm 1 using this probability of firm 2 is U1. EU1 lobby means 5Q plus 15, 1 minus Q. Here, minus 5Q. Why minus 5Q? Because the expected payoff from lobby, farm 1 get expected payoff from lobby is minus 5 and not lobby is 15. So minus 5 is with Q and 15 is with probability 1 minus Q. And if farm 2 chooses not to lobby, its expected profit is now 0Q because not lobby is paying 0 for farm 1 and 10, 1 minus Q because 10 is payoff from not lobby. So if farm 1 mixing between lobbying and not lobbying, it must be indifferent between these two choices in case of mixed strategy. Otherwise, it will be better for this farm to take the pure strategy for getting the highest possible payoff. Hence, we must have that EU1 lobby is equal to EU1 not lobby. Rearranging and solving for probability, Q equals half. Therefore, farm 1's strategy against farm 2's probability of selecting lobby are indifferent when Q is equal to half, lobby when Q is less than half, and not lobby when Q is greater than half. This can be found, let's take the middle one. This can be found, suppose lobby is the strategy for farm 1. So 15 payoff from lobby 15 minus 20Q is greater than 10 minus 10Q. So 15 minus 10 is greater than 20Q minus 10Q. That means 5 should be greater than 10Q. Q should be less than half. So that is what we have found for lobby. For lobby, Q is less than half. Similarly, for not lobby, Q is greater than half. And for indifferent relation, Q is equal to half. So therefore, firm 1's strategies against firm 2's probability of selecting lobby are indifferent when Q1 when Q equals half, lobby when Q is less than half, and not lobby when Q is greater than half. Now take P as the probability of firm that firm chooses lobby, and 1 minus P the probability that firm chooses not lobby. Then the expected profit of firm 2 playing lobby is U2 lobby minus 5P plus, that means minus 5P plus 15, 1 minus 5P. So minus 5P plus 15, 1 minus 5P. So equal to, this is equal to 15 minus 20P. And when firm 2 chooses not lobby, its expected profit will be 0P, that means here 0P, and 10, 1 minus P. So firm 2 must be indifferent between lobbying and not lobbying. Solving for P yields P equals half. Therefore, firm 2's strategies against firm 1's probability of selecting lobby are indifferent when P equals half, lobby when P is less than half, and not lobby when P is greater than half. And this is this calculation is equivalent to the previous calculation in for firm 1. So let's take this as an example. So not lobby. So for not lobby, firm 2's strategy of not lobby means that 15 minus 20P is less than 10 minus 10P. So 5 should be less than 10P. So P should be greater than half, because this part is for lobby and this part is for not lobby, and for not lobby being greater than the lobby, the firm 2 will choose this strategy. So the probability of firm 1, if the probability of firm 1 is greater than half, then the firm 2 will choose no lobby. If it is, if probability is less than half, the firm 2 will choose lobby. So this is for no lobby, and this is for lobby. And when P equals half, firm 2 will choose, firm 2 will be indifferent between these two choices. So we can say that mixed strategy Nash equilibrium, MSNE, can be
described as half lobby, half no lobby, and half lobby and half no lobby. And this can be taken as P 1 minus P Q 1 minus Q. All right. Now, what about C? C requires to represent graphically each player's best response function in the MSNE, mixed strategy Nash equilibrium. So here is a reminder for farm one's strategy. So for farm one, for any Q greater than half, farm one decides to play no lobby, as we see in the above set, that Q is greater than half means no lobby. Farm one plays no lobby in pure strategy. This implies that P equals 0 for any Q is greater than half. We know that P is equal to 0. That means 1 minus P equals 1, which means 1 minus P is no lobbying. So that's why farm 1 plays no lobby when farm 2 plays, farm 2 has this strategy. Probability of playing lobby is Q is greater than half, as depicted in the vertical segment of BRQ. This segment, vertical segment of this dashed line BR1Q that overlaps the vertical axis. So this portion, that means left hand side of the figure 3.4. So farm 2 is likely lobbying. That means if farm 2 plays lobby, that is Q greater than half, farm 1 prefers not to lobby. Okay. So similarly, for any Q less than half, farm 2 is rarely lobbying, so which induces farm 1 to lobby. Therefore, P equals 1 as illustrated in the vertical segment of BR1Q in the right hand side of this figure. So vertical segment means this one to the right, and vertical when Q is less than half. So Q is less than half means P equal to 1. See, P equal to 1 here. And this segment is when Q is greater than half. That means P equal to 0 implies 1 minus P equal to 1, which implies no lobby. Okay. And this implies lobby. No lobby. The horizontal segment of BR1 means that in this segment, Q equals half. That means farm 1 is indifferent. What about farm 2? Similarly, for if strategy P is greater than half, farm 2 is better off not lobbying. Here you see that greater than half means farm 2 is better off not lobbying. Hence, Q equals not lobbying means Q equals 0. For any P greater than half, that means BR2P represents the horizontal segment of, that overlap the horizontal axis. So this part where P is greater than half, Q equals 0 means no lobby. Oppositely, when P is less than half, farm 2 is better off lobbying. So if it is less than half, farm 2 is better off lobbying implies that Q equals 1. So when P is less than half means farm 2 less than, if farm 2 is better off lobbying, that means lobbying means Q equals 1. For any P below half, intuitively farm 1 is likely not lobbying, making lobbying more attractive to farm 2. This result is graphically shown by the horizontal segment of BRP2. So this segment where Q equals 1, this Q equals 1. Okay. And this segment is when Q, when P equals half, Q is also equals half. We can combine the figure 3.4 and 3.5 into one graph, 3.6, lobbying game, best response function. We can see that there are 3 intersecting points between the best response function. So both best response function intersects 3 times. Crossing points of both best response function identify 2 PSNE. That means one is here, other is there, and the third one is here. So this one is when P is less than half, Q equal to 1. This point is when Q is less than, when P is greater than half. Also here, okay, so this point is when Q is less than half, P equal to 1. Here P equals 0, there Q equals 0. So pure strategy is Q equals this pure strategy means Q equals 1, P equals 0. This pure strategy is P equals 1, Q equals 0. And this is MSNE, and MSNE represents half for P1 minus P, and again half Q1 minus Q. So this ends 3.2. Let's move to 3.3. 3.3 is very, so 3.3 is like 3.2. 3.3 is variation of the lobbying game, like 3.2. Consider a variation of the above lobbying game as follows. So the difference between 3.2 and 3.3 is here. In case of lobby, no lobby, there is a figure x minus 15. Previously, it was 15, 0 in 3.2. So as depicted in the matrix, way of matrix, if farm 1 lobbies, but farm 2 does not, farm 1 lobbies, but farm 2 does not, Congress decision yields profit or payoff x minus 15 for farm 1, and where x is, the condition is x is greater than 25 and does not yield any profit for farm, that means 0. So farm 1 gets x minus 15 and farm 2 gets 0. And all other cases remain the same as we have seen in 3.2. We are requested to find pure strategy Nash equilibrium of this lobbying game, mixed strategy Nash equilibrium of this lobbying game, and we are asked to find what is the probability that the outcome lobby, no lobby occurs. And finally, how the result in part C varies when x increases. So when x increases, we know that x is greater than 25, but if x increases, what happens? That is what question 3.3D wants us to interpret. So let's start 3.3a. Solution to 3.3a. As we did in 3.2, let us first examine the farm 1's best response function. In particular, we write that BR, so BR1 lobby is no lobby, underline is no lobby because minus 5 is greater than less than 0. So when farm 2 does not lobby, so when farm 2 has this strategy, farm 1 prefers lobby because x minus 15 is greater than 10. X minus 15 is greater than 10, or x is greater than 25. So when x is greater than 25, that means x minus 15 is greater than 10. That's why we underline this one. So for against the strategy of farm 2 no lobby, farm 1 chooses lobby. That means this one, we underline this. Similarly, when farm 1 chooses to lobby, so if farm 1 chooses this one, farm 2's best response function is no lobby. Why? Because 0 is greater than minus 5. So farm 2 has two options against the lobby of farm 1. So here this option is minus 5 and 0. So 0 is greater than minus 5. So BR2 is no lobby. When farm 1 selects not to lobby, if farm 1 selects this one, farm 2's best response becomes 15 because 15 is greater than 10. Therefore, with respect to farm 1, this one is, there are two PSNE, lobby, no lobby, this one, and no lobby, lobby, no lobby, lobby, this one. In terms of farm 1, now B asks you to find mixed strategy Nash equilibrium. Sorry, this is not the PSNE, this is MSNE. Of the lobbying game. If farm 1 is indifferent between lobbying and not lobbying, it must be that EU1 lobby equals EU1 not lobby. That means, as we did in 3.2, minus 5Q this times Q and that times 1 minus Q equals 0 times Q and 10 times 1 minus Q. So simplifying, we get the equation for Q, and this is the equation for Q, where farm 1 is indifferent. Similarly, for farm 2, farm 2 must be indifferent between lobbying and not lobbying, no lobbying. When EU2 lobby is equal to EU2 not lobby, this implies this times that plus 15 times that should be equal to this times P plus this times 1 minus P. And solving for P, we obtain P equals half, for which the farm 2 becomes indifferent between the two strategies. So hence the MSNE is half lobby, half no lobby. When P equals half, 1 minus P is also equals half. And when Q equals 25 minus X, 25 minus X upon 20 minus X. So 1 minus Q is equal to 5 divided by 20 X minus 20. Now, 3.3c requests us to find, analyze MSNE found in part B. What is the probability that outcome lobby no lobby occurs? The probability that lobby no lobby occurs is given by the probability of firm lobbies and P times the probability that firm 2 not lobby. That means this is with probability P and this is with probability 1 minus Q. So joint probability is P times 1 minus Q. So we know that P equals half and Q equals 25 minus X upon 20 minus X. So we get this, the probability. After simplifying, we get this probability P 1 minus Q equals half 5 X minus 20, because this is actually 1 minus Q. Now D requires to explain how the result in part C varies as X increases. In order to do that, we have this result for the probability of lobby and no lobby. This is P and this is 1 minus Q. So we need to find what happens when X increases. The probability outcome lobby no lobby. This outcome is P times 1 minus Q decreases. You can see that because X is in the denominator, so when X increases, so P 1 minus Q is gonna decrease. We can see where if we take the first derivative of this with respect to X, we find this minus 5X minus 20 square, 5 upon 2 times X minus 20 square, which is less than 0. That means negative, because there is a negative sign here and the denominator is square. So this can be shown in figure 3.7, the probability outcome as a function of X, which is negative because we know that X is greater than 25. So when X is greater than 25 means this part is negative. No problem if this part is negative, no problem. But if it is positive, still the whole part is negative. because this is square. So the joint probability decreases in X. Now, the last question is, what does the result in part C varies as X increases? When X increases, the aggregate payoff outcome, lobby, no lobby, that means lobby for farm 1 and not lobby from farm 2 is X minus 15 plus 0. Let's see what the matrix. So this plus that is the outcome of lobby, no lobby. So when X increases, the aggregate profit exceeds the aggregate payoff from the other strategic profile that becomes socially optimal. So when X increases, this becomes, although this is, Nash equilibrium, we're not sure whether this is socially optimal. Optimal in the sense that Nash equilibrium, but we're not sure whether it is socially optimal. So when X increases, it is also socially optimal. Why? Because the aggregate payoff exceeds the aggregate payoff in other. So aggregate payoff here is minus 5 plus minus 5 equals minus 10. Here is 15. Here is 20. But there is X minus 15 plus 0. That means X minus 15. So X minus 15. So depending on, so if when socially optimal means there is a condition for socially optimal to be that payoff to be socially optimal. That means any to be socially optimal if X minus 15 is greater than 10 plus 10. That means this part, because this is the largest other than this, because the lobby is minus 10, lobby is 15, but no lobby is 10 plus 10 is 20, so it is greater. So if X minus 15 is greater than, so then the lobby no lobby becomes socially optimal. So we can find a condition for X is greater than 35. So this implies X minus 15 should be greater than 10 plus 10. So X should be greater than 35. If this is the condition, then lobby, no lobby becomes socially optimal outcome, as well as pure strategy Nash equilibrium. Okay. Why? Because if it is, suppose it is X equals 35. So X is 36. So if X is 36, then 36 minus 15 is 21. So 21 plus 0 equals 21. It should be greater than 10 plus 10 equals 20. So no lobby is 20. Now X is, if X is 36, which is slightly, X is slightly more than 35. So if X is 40, then obviously it is the lobby no lobby is socially optimal because it is more than n plus 10 equals to 20. This ends our problem number 3.3. Our next problem is 3.4. Thank you.